I'm Stephanie Hendrixson, and I want to welcome you to something new on the Additive Manufacturing YouTube channel. This is an excerpt from our podcast, AM Radio. In this episode, Pete Zelinski and I take a look at the 7 families of additive manufacturing technologies and consider whether those groupings still make sense. You can learn more about the podcast and how to subscribe through the links in the video description, and if you like what you hear, let us know. We'll post more of these to YouTube. And now, AM Radio.
Hey, welcome back. So before the break, we were talking about some unusual 3D printing processes. Stephanie and I were sort of shaming one another with our lack of fluency in different obscure additive processes. But it touches on a point that I've thought about from time to time, which is we have a set of widely accepted industry categorizations for different 3D printing processes. But as 3D printing technology continues to advance and new processes are developed, I'm feeling those categories straining, and they seem less and less useful for containing and defining all of the options that are out there. And maybe we could explore and talk about that a little bit.
Yeah, I mean, I think some of the processes that we discussed in the first half of the show, they come across as strange because they're sort of like straddling a couple of these categories. But maybe just as a baseline here, the things that we're talking about, this is the 7 families of additive manufacturing. It was developed by an ASTM committee, the Committee on Additive Manufacturing Technologies, and they published it in 2010. So it is 12 years old at this point. But basically what they've done is created 7 process classifications for additive manufacturing. And those processes are binder jetting, directed energy deposition, material extrusion, material jetting, powder bed fusion, sheet lamination, and vat photopolymerization. And for each of these, there's sort of a description provided, there's some strengths listed, some typical materials, but as we've been talking about, these 7 categories don't quite stand up to every potential 3D printing process we might throw at them.
Right. And for a categorization system, sure, there can be exceptions and there can be a miscellaneous bucket. But if your exceptions and your miscellany gets to be too large, then you have to question whether the categorization is still working. And we maybe saw hints of that in the processes we were talking about in the first half of the show. Like, let's go back to them for a moment and see if we can get them to land in categories.
Sure.
The one you started with, for example, multi-jet fusion. You asked me to describe that. So sure, that is a powder bed fusion process. And I think most people would place it as powder bed fusion. But the thing of it is, so that process appeared and was adopted after this categorization system was written. And when almost anybody who's in the additive manufacturing space thinks about powder bed fusion, like they're not thinking about multi-jet fusion. Like it's not what comes to mind right away. In part because, this is a little bit of a stretch maybe, but you could make the argument that binder jetting is also a category that multi-jet fusion could land in. So it's not a clean fit with either category. And so that sort of speaks to a challenge of this system.
Yeah, and the other weirdness, just sticking with multi-jet fusion and putting it maybe in the powder bed fusion category right now, that category is also strange because it includes both polymers and metals. So is multi-jet fusion the same as electron beam melting or the same as selective laser melting, both of which are metal processes that use either an electron beam or a laser to sinter point by point or melt the powder point by point?
Right. I think we're going to circle back to that. There's a lot going on potentially in a powder bed machine. And so just saying powder bed, is that really a descriptive enough category to draw all these processes together?
But it's limiting at the same time because, as we talked about with grid logic, they call their process a powder bed technology, but it's not powder bed fusion because the fusion happens later in the sintering oven.
Right. Okay. So what is grid logic? How would you place it in these categories?
It's more like binder jetting, but there is no binder to jet. So it's binderless jetting.
Okay, so yeah, grid logic doesn't land well within these categories. Meld's process, friction stir welding, where does that go? I could get semantic about it. Is it material extrusion? If you've got bar stock that's being fed down onto the workpiece, that's not really extrusion. And is it directed energy deposition? Well, I mean, there is energy involved in applying force and friction to the workpiece, to the material, But that's really not the kind of directed energy we're thinking of when we think of that process. So it's like you're looking for the best wording to fit, even though whichever category it goes in, it doesn't like fit the other things in that category all that well.
Yeah, so for whatever reason, like directed energy deposition, we expect to like see a spark, visibly kind of see the energy happening. And with Meld, you don't really get that visual. Like you see the layers building up, but it doesn't look the same as other DED processes. And there are lots of other things that sort of, I guess you would have to throw in that category that maybe don't belong there either. I'm thinking of like some of the cold spray processes like Speed 3D, where the metal is building up, but the energy is just like really fast air. It's not causing a spark. It's not, oh, cool, it's melting in the same way that some of these other processes are.
Yeah. The thing you said at the beginning there, how you expect a spark. And so that sort of gets at these 7 family categories are semantic word sets. But then there's this other thing, which is our intuitive sense of what processes kind of go together. And there's this growing mismatch between the intuitive clumpings that we talk about and these kind of long-standing now categories.
And so are the categories still useful?
They are, because as we sort of got to in the first half of the show, the range of process possibilities continues to expand. New processes are coming, and when we're in motion in this space, we have to explain them to one another. And these well-established families at least offer a reference point for defining processes and comparing them to one another. So like vat polymerization is getting stretched a bit because there are a couple or a few different options now for what looks like vat polymerization, except there's no vat involved, or at least the part is not growing in a vat. But we can at least say like, well, yeah, it's vat polymerization except without the vat. Like there's a way to talk about it thanks to these terms.
Yeah, so like Massivit falls into that category, and some of the other processes that we've seen recently, like BCN 3D, fall into that vatless photopolymerization sort of thing. And so maybe there's a way to sort of like broaden the categories. Like, could we just call it photopolymerization and drop the vat conception?
Yeah, so that's an easier one. Like you asked if the categories are still useful. I guess one of the challenges of the established categories, and maybe one thing that's a little unfair about them is, and this was sort of Ben Arnold's point with tritone, and again, he wants to advance tritone's technology. He's selling tritone machines. So, but his point is kind of like, why should this process be weird, but binder jet feels more mainstream? And part of that is just because, yeah, binder jet's been around longer, but also there's the fact that binder jet is one of these terms in the 7 families. That is sort of an arbitrary choice that may or may not be representative of how these technologies will ultimately, when everything is mature, be accepted and be thought of.
So longevity played a role here because not everything that we're talking about today existed in 2010, and it makes sense that some of the categories that were established here are getting stretched now with new information, new developments.
So yeah, longevity is for real, and processes that have already been proven and been accepted certainly deserve to be understood that way and have their place as references for what comes next. But is it useful to lock in these processes established only fairly recently as sort of the structural defining points for the ways we organize additive going forward? Like you mentioned powder bed fusion, and it both includes a whole lot that maybe doesn't go together and is also limiting in terms of what it implies or what it leaves out. Are there different clumps we could find as a thought exercise that might describe alternative ways to group these technologies?
Yeah, I mean, I think there are. I think they would have to be maybe a little bit broader than what is presented here, or maybe you need more categories and they need to get narrower. So like, does grid logic become part of a powder bed category instead of powder bed fusion? Or do you create subcategories where powder bed fusion is for things that use lasers and electron beams, and there are other ways of using powder that become their own category, maybe?
That's a good point. Take the fusion out of it, and let's make the powder bed the commonality. So I wonder if, rather than the powder bed being the commonality, are there other commonalities we could find? What if we said laser-based processes? And that would bring in laser powder bed fusion, but also deposition processes that use lasers. And if you clumped it that way, that would leave out, for example, electron beam processes, which are a different form of powder bed fusion that addresses different kinds of parts. The categories now have powder bed as the commonality. We could have the type of energy source as the commonality and segregate the processes that way. So laser-based processes, like we could accept that or not, but it is another way of clumping.
Sure.
Another clump concept. Processes that need sintering, like metal part processes that either need an oven or don't need an oven at the end of the build.
Well, I would expand that because you'd have to put ceramics in there too. There are a lot of ceramic printing processes where you're using a slurry or something and the part is not going to be done coming off the printer. It also needs that sintering step.
Yeah, so noted. So processes in need of sintering, like that's binder jet, absolutely. It's the tritone mold jet process we mentioned, but it's also FDM processes, FFF processes that deliver metal powder and produce a metal part that also needs sintering to complete it.
So you're thinking things like Rapidia.
Or the Markforged Metal X process, or the way Desktop Metal does its studio system. So their process, bound metal deposition. It's fused filament fabrication using polymer to deliver metal powder. Make the part that then needs to be sintered.
Yeah, so that's one of those things that did not exist, to my knowledge, in 2010. But we're seeing several different ways of doing metal FFF by extruding a filament of some sort that contains metal powder and then sintering it after the fact, whether that's a dedicated system or I think BASF has a material for this that you can use on like an Ultimaker or other types of desktop printers. And yeah, like the question of where to put that and does that belong with the other extrusion processes, if you think about it instead as these are all things that need sintering, it kind of has a home that it maybe doesn't have right now.
Yeah, that's right. That's another example. So these processes delivering metal with a polymer agent. So yeah, it is fused filament fabrication. And so the specific category it would land in is material extrusion. But the extrusion doesn't tell the whole story.
Yeah.
Okay, so here's one more of these I've been thinking about. Solid state versus non-solid state processes.
Oh, okay. So this is a place to put things like Meld and maybe the Fabrasonic, ultrasonic additive manufacturing, where the material is not melting. It gets to be in the solid state category, and the processes where there's like a laser or there's an electron beam or heat is being applied, like that would go into the not solid state category.
Yeah, 3D printing. Ultimately, this is a materials engineering technology every bit as much as it's a geometry creation technology. And these categories focus on how the geometry is created. But yeah, that distinction, does the metal need to melt or not? That has obviously like tremendous implications for the material properties and the microstructure coming out of the process.
Okay, so these are some compelling arguments and some interesting potential categories. I agree with what you said earlier that the categories are useful in that they allow us to kind of talk about these different processes and sort of understand them. Like if you came to me and started explaining something and said, well, it's kind of like binder jetting, like I would get that and I would understand it more quickly because I have that framework already. But I would kind of argue that these categories are sort of artificial in the sense that I don't think people coming into additive manufacturing, like those manufacturers we write about that are experimenting with 3D printing and pursuing business opportunities through 3D printing, I don't think they're thinking about it in these terms. At least in my experience, the stories that we've heard, it seems like people approach this more from like a materials standpoint or a size standpoint. Like they have something specific in mind and they need to find the right material and the right build volume that can do it. And they're not thinking about it in terms of, well, I want to buy a directed energy deposition machine. Which one should I choose? It's, I need this type of aluminum and I need to be able to build it this big. And that's what's going to decide the ultimate technology purchase that they make.
That's well said. Like what I hear you saying is these 7 families say that is a way of thinking about this that's useful for discussion within the additive manufacturing community at large. It's really not a useful interface for process selection when you've really got a job to do or a part to make. You've got other decision factors that you're thinking about. It guides you to a process, and that process lands well within these 7 families or doesn't land well within those 7 families, but that's something you might discover or think about later, and it really is not relevant to how these processes get adopted.
Things that we think of as weird because we're familiar with these categories and we see that the process doesn't quite fit into the category. Someone who's going to use that and find good use cases for it, they don't necessarily care what category it fits in. They might discover it later and think, well, okay, this is sort of strange and maybe not everyone is doing what I'm doing. But if it works, if it does what you need it to do, it sort of doesn't matter.
Oh, totally right. That brings us right back to where we began. Multi-jet fusion, it was weird when it was introduced, and it clearly won adoption. The weirdness did not stand in the way.
Yeah, for sure.
Let's pause this conversation for now. This is a really interesting topic that connects to a lot, and we'd love to hear from you about this. We'd love to hear from listeners. What thoughts do you have about the ways to categorize, organize, define the ever-expanding palette of additive manufacturing processes? You can find us anywhere. Stephanie Hendrixson, Peter Zelinski. You can find us on social media. The Additive Manufacturing Media brand. You can find it on social media. Reach out to us through any of those channels. Would love to hear your thoughts on this.
And if you enjoyed this episode of the show, you want to hear more AM Radio, make sure to subscribe. You can find us on iTunes, on Spotify, anywhere that you get your podcasts. Thanks for listening. AM Radio is recorded with help from Austin Grogan and Seth Cooper. The show is edited by Alex Lytle and me, Stephanie Hendrixson. Our artwork is by Kate Bilberry. AM Radio and Additive Manufacturing Media are products of Gardner Business Media, located in the Queen City, Cincinnati, Ohio. I'm Stephanie Hendrixson. Thanks for listening.